Good morning, everyone. How are we doing today? What a beautiful day Christchurch has put on. Hey, it's my pleasure to welcome you all to the 6th Green Grid Conference. For those who don't know me, I'm Stephen Jay. I'm the General Manager of Grid Development at Transpower, but my role in this project, in terms of the Green Grid project, has been something slightly different. From the agenda today, you've all got a copy on your seat or grab one on the way in. You'll see there's quite a range of topics, both from industry and the academic world. I'm not going to dwell on those, but I would like to say a few words about the industry component. You roll back about 4 or 5 years when this project, the Green Grid project, got underway. Peter Berry from the EEA, who I'm sure many of you will know, gave me a tap on the shoulder and said, how do we get the industry involved with the work within the academic area where funding's being allocated? And he goes, you're up for the challenge. Like, how can we get a group of people involved who can help and integrate that academic work with the industrial world? And I thought, I'm on for that. I know a lot of people. So working with Alan Miller at the time, we approached quite a few people across industry to form an industrial advisory panel. Now, how many of you, just a show of hands, were aware that there was an industrial advisory panel as part of Green Grid? A few of you. Let me spend a little bit of time just explaining what we do. So it was a collective group from industry. They were all volunteers and they all came from different walks of life. I'm actually going to name them in a minute because I think it's important that we get recognition from the people involved. The IAP was formed to help out, to form that link between industry and what industry were doing, what industry had and the information they had, and what would help in terms of the research around the Green Grid project. I'll never forget sitting at one of our first meetings back in, I think it was the 24th of June 2015, where I think one of the academics turned around and said, we'd like some data from meters. And what was the first response we had from the industry? No, it's top secret. Yeah. And the academic said, yeah, that's why we can't get any. Yeah. So through the IAP, we managed to wrangle a way of actually getting access to some of the information, to take the confidentiality off some of it, to take that sensitivity off and allow it to feed through to some parts of the project to really help things out. The IAP met every quarter for the first couple of years of the project. Then post back, we then wound it back to only cover things every 6 months. It's a really good bunch of people. I like to thank them. I'm going to run through their names now. So Nigel Purdy from Unison was involved. Roger Miller, I think Roger's here today, somewhere in the middle. We had Eric Livingood and Conrad Edwards from Transpower. Taz Scott from Midding Electronet. I've seen Taz today. Where are you, Taz? Beautiful. Gareth Wilson from MB. Gareth's here today. Glenn Coates from Orion, although he's now changed roles. John Welch from Vector. And then later on, Rhino Versler from Vector got involved as well. You can tell how old this is because many of these people have now changed jobs, but it's a small industry. Neil Chen from Fisher Paykel Appliances, Peter Doyne from Meridian, Jimmy Silk from Paraco, and of course on the Green Grid side, many of the meetings were attended by Alan Miller, who ran the research at the time, Srijan Panji, and of course Lindsay provides a lot of our notes and kept us all online. So can I just personally thank all of those people for helping me out in terms of chair of the IAP, to actually contribute to the research and link it in. It's been a fascinating time, and without your contribution, we wouldn't, I think, got as far as we did. Today, we've got a really good lineup, and it's really pleasing to see such a wide turnout here today from all walks of life. It's really important that we can conduct research in New Zealand, which contributes to adding value, that allows us to move forward, allows us to bring in both a local and a diverse international perspective into things. You'll hear about some of those elements today. So I won't dwell any more in terms of my brief intro. I would again like to thank you all for coming today, and I'm going to pass over to Alan Woods.
Well, thanks, Steve, for that introduction. It's always nice to kind of know where the roots of these things come from. So, like I said, big thank you to the conference sponsors. They are Transpower, Orion, the EEA, and ECA as well. So they've kind of paid for the support, the lunches and everything else for this. So big thank you for that. Without that support, this conference wouldn't run. Right, so I've been tasked to take kind of the first talk, which is green grid summary and findings. And when I first thought about this, I thought, oh my goodness, how can you summarize 7, nearly 8 years of research work? It's really tough. There's been a lot of people involved, both researchers and in industry, and the contributions have been huge right across the board. It's really impossible for me to go through all the detailed outputs. So all I'm going to do really is give kind of a broad summary. So this is what I'm going to talk about. First of all, the organisational structure, because it was quite a big project, and the organisational structure, I think, what was a very important part of the Green Grid Research Programme's success. A bit about what it's all about, which is really the impact statements, where we sort of tried to make a difference, and some of the key outputs from that, and then a very short slide on possible future work, although this is really the swan song for this project. So I guess MB went to industry 7, 8 years ago and asked what the pressing questions were. Back in those days, EVs weren't really on the horizon, but photovoltaics and renewable energy and the low carbon future was starting to be a bit pressure. So they had this kind of big question about how we're going to manage renewable energy, variable renewable energy in our network. So they put out a request for proposals, and we submitted to that, where we were really answering the questions they were asking. So it's quite directed by those questions. So originally directed really by and co-funders came on board as well. So Transpower and the EEA were really fantastic contributors, both with in-kind and money as well. Steve's talked about the industry advisory panel, and they helped shape the initial direction and provided guidance and data and insights right through the whole project. And as part of that, we formed a network analysis group as well, which was a more specific technical group. I have to say that the industry contribution to this project was huge. I think in academia, it's easier to head off down pathways that are perhaps less than useful. But the industry input here did keep things really on track and kept us grounded. So like a huge thanks to the industry contribution. And of course, with that, lots of supporters from the authority and lines companies around the place who have provided us with data and insight and time, which has just been fantastic. On the right-hand side, the kind of research side was done at 3 universities, so led at the Epicentre, University of Canterbury, but with strong contributions from the University of Otago, CSAFE, and University of Auckland as well. So really quite a big team with a variety of skills. So the original key questions were, I guess there were 2. One was to identify and manage. And people thought that it was going to be the variability of renewable energy that was going to be the problem, and that managing too much power when it's too windy and not enough power when it's not windy and there's high loads would be the trickiest thing. So that was the kind of real focus back then, and that has kind of changed through the course of the project, I'll talk about. And the other big part of it was to make sure that distribution networks were able to take additional renewable generation in a cost-effective and safe way. We quite quickly realised that although there was a lot of talk about these issues, there was very little quantification going on. So we really set about trying to quantify what these issues might be. So I'm just going to go through some of these things. It really started out with solar panels, domestic solar panels mostly, which was just starting to boom back in the day. We developed an economics calculation tool for that, which morphed into the Eco Solar Calculator, although it wasn't the intent at the time. And that was actually used to forecast what uptake rates might be. And coupled with that, we looked at the variability of sunshine, had some interaction with NEOA and also looking at satellite images and the like, but established the power variability, and then the effect of aggregating that on a regional basis, which I think in the end Transpower used that for their generic eco report. So the outputs from that were the Eco Solar Calculator, which you'll hear about later on today, and photovoltaic data sets and an analysis methodology, which has stood the test of time. So as part of that, solar panel technology was being taken up by domestic consumers, and I guess they're a group that have not been very well engaged in the kind of power supply and delivery process, and how they're communicated with is a bit to understand what people want to do and why they want to do it. So this kind of fell onto Otago CSAF's brief, was to look at household consumption profiles down to the appliance level, look at what they kind of are hoping and expecting from photovoltaics, electric vehicles, home energy management systems, and see what the potential was for demand management involving people that are not our employees. So we've got some key outputs here, which were insights into current residential demands and future trends from people's expectations. And as part of that project, there was a long-term monitoring of 42 households with multiple circuits inside the houses to see where the power is being used and by what, to try to inform what's going on in houses. Right, so back to variability. Wind power was the other sitter for variable energy supply in New Zealand, and those kind of longer term variability was reasonably well known, but the shorter term variability not so much. So we looked at some scenarios from kind of what we have at the moment, up to 4,000 megawatts extra of wind, so quite a bit, and distributed around the country in different ways. Then from that, managed to get a sort of speed and power imputation from 6 hours down to 1 with aggregation to see the national effect of wind power. So that work was done by Dougal McQueen, who I did see in the audience before. So with the wind variability and the solar variability, I guess that the solar was far more likely to end up in distribution networks. So the second step was to look at the impact on the network. So we looked at LV network modelling, and again, great thanks to a number of lines companies. Orion were the first, but Well and other networks provided us with their low voltage network, enabled us to stochastically plant PV systems in those networks to look at what happens with voltage and current issues. So there's going to be over voltage or under voltage. Over voltage is mostly with photovoltaic. And some overloading of conductors transformers. That gave us a tool by which we could measure these impacts. EVs, although not part of the project, have kind of crept in, and you'll hear about that a little bit later on in the talk. And of course, we had Professor Neville Watson looking at the power quality and impacts from harmonics, and particularly, I think, identifying that high frequency harmonics are much more of an issue than what people thought. Quite a bit of information went out from that and lots of measurements. So some key outputs from this were a guide for the EEA on how to connect small-scale inverter-based distributed generation, a hosting capacities tool to figure out how many PV systems that a network could take. As a result of all this, of course, PV inverters have some functionality, and we had quite a lot of input to AS/NZS 4777, which is what inverters should do when they're connected to a network that was specific to New Zealand voltage levels. Got PQ measurements and recommendations, and some protection guidelines as well to make sure that LV networks are still safe. All right, so Ewan's going to be talking about EV impacts at 11:40. Ewan McGill. So we kind of covered local impacts, and that aggregates up to national impacts. And I guess that variability can be long timescale variability, sort of interseasonal variation, or short timescale variability, which is what people were mostly worried about. So on the short timescale, then the worry was to balance power. And so when it came to quantify that variability with all the data, then it turned out that the variability from renewable generation was going to be less than the variability was when there was an arc furnace operating. So actually the variability wasn't really the issue, although people thought it was. What was more of an issue was how it changed the generation mix and how it changes the characteristics of the power system. So inertia and risk change, and ancillary service requirements change. I think Josh Shipper is going to talk about that at 11:20, so I won't say anymore, Josh. But we do have a dynamic frequency model published for New Zealand now, and probably more importantly is a reserves optimization methodology, which could introduce reserves into the market in a more fit for purpose way. And then there's the long scale variability. So with our seasonal variation of hydro inflows, the dry year problem, then have to make sure that we have enough energy to supply New Zealand's electricity needs from year to year. Have to make sure that the storage can be managed to meet those peaks and troughs. And as part of that, there was a bit of hydro resource assessment as well to see what extra possibilities there are in New Zealand for that. So I guess a key output from that is we have a simplified New Zealand dynamic programming optimization model, which is trying to show how much storage can do to mitigate this seasonal variability of renewable generation. And in fact, I'm going to talk about that at 10:40, so not so very far away. Overall, there's been quite a lot going on with the project. You can see here that we've got 10 peer-reviewed journal papers, conference papers, 100 conference presentations, 130 workshops. I think that comes from our industry connection, where we're really trying to get information out of industry and find out what the problems and needs and issues are from industry as well. Lots of reports on white papers, lots of EEA conference papers, and 8 postgraduates sort of involved in all this work. So quite a lot of output, but quite a big team as well. So Isabel worked through to see who had worked on this project, and you can see it's really a very long list over the years of people who've contributed to the project, but I would say have also learned from the project and taken that with them in their career. So it's really very heartwarming to see. Of course, just because the timeline of the project is finished doesn't mean that there's still not things to do. So although we've kind of met the project requirements, as I say, it ain't over till it's over. So there is more work to be done, and I think the kind of EV management thing is certainly a rising issue at the moment. But I think that batteries becoming more common in distribution networks. EVs are as well, so that whole distributed technology space is getting quite busy, and that provides some issues and some possibilities as well. So I think it behooves the industry to sort of take advantage of the opportunities that are being offered by this, and I guess manage the difficulties that will be introduced. So the other thing that's really happened over the last kind of 10 years is that really monitoring, detection and communication for waveform analysis and for asset condition monitoring. Technology is getting quite cheap. Processing power is pretty cheap now to distribute around a network. So I think we're at a phase now where we're going to start learning a lot more about networks that have been largely invisible to distributed companies today. So kind of a big change coming up, which we'd like to be part of. And I think finally, of course, all of this was only made possible by our supporters. MB, of course, was the main funding supporter, and our co-funders, and then lots of researchers and sponsors, for whom I expressed my kind of heartfelt thanks, because it's been a great interaction both ways. I have to say personally, it's been a big project and a long journey, and I've really enjoyed it, but it's been a lot of work as well. So it's with some sense of sadness I feel it coming to a close, but also obviously anticipation about what's to come. Anyway, that's my talk. Thank you.